Welcome to iComply365's webinar, Everything You Want to Know About Encryption for GDPR Compliance, but We're Afraid to Ask. Our goal today is to provide you with an objective framework for making decisions about the adequacy, cost, and cost of existing or proposed encryption solutions. We're going to go over what the GDPR expects encryption-wise. We're going to talk about how to evaluate existing or proposed encryption solutions. And we're going to talk about tools for documenting encryption for GDPR compliance. So obviously we all know GDPR expects the data to be protected. And to them that seems to mean no reportable breaches, right? In encryption, the purpose of encryption is to not have reportable breaches, because if things are properly encrypted, then they're unusable by whoever manages to get access to them that should not have access to them. Now, there are different kinds of breaches. There are confidentiality breaches. We're all familiar with those, but they come in different flavors. There's infiltration, and this is basically the unauthorized access to data, and that can be unauthorized access inside an organization. Somebody views something that they're not supposed to have access to. It can be from outside an organization. Perhaps somebody has compromised the credentials of a legitimate insider and logs in and sees things that they're not supposed to see, or perhaps they have installed malware and gotten access through elevated privileges, something of that sort. Then you get exfiltration, where the data actually leaves the organization. Unauthorized copy and transfer takes place to some unauthorized device on the outside of the organization. And lots of ways that this can happen. It can happen via email, via text, via a portable media. Again, malware just slowly exfiltrating data out over time. But the important thing to understand is that data leaves the organization. So, and there's interception, the capture of data in transit, which is always a bit of an issue. And then there are integrity breaches. And encryption plays in this because encryption is able to cryptographically tell whether or not data has been altered in some way that it was not supposed to. So these integrity breaches are when you have unrecoverable accidental or malicious data alterations. The key word here is unrecoverable. If you have cryptographic protections that tell you that the data has been altered, regardless of the reason, if you're able to roll it back to a known good state, it's not a breach. Then you have availability breaches, and we normally think of those as denial of services or the distributed denial of services attacks that shut down systems and websites and so forth. And encryption has a lesser role to play in availability breaches in terms of GDPR compliance. So our primary concern is confidentiality and integrity. So GDPR makes it pretty clear that they expect an assessment of encryption solutions, and this includes obviously systems that are already in place for data protections and systems that you might be contemplating acquiring. In their guidance, Working Party 29 guidelines on personal data breach back in October of 2017, so a little over a year ago, they stated a failure to comply with Article 33, the breach notification standard, will exist where a controller does not notify the supervisory authority in a situation where the data has not actually been securely encrypted. What I want you to note in the highlighted passage is the not actually. It doesn't say just where the data has been securely encrypted. It means that it actually has to have been securely encrypted, and you may wonder why they put that language in there. Then we see that they also say you have to carefully weigh the quality and proper implementation, which kind of implies that you can have an encryption solution that doesn't have good quality or is not properly implemented, and they recognize that. And that's understandable because, unfortunately, the cyber history is replete with examples of people who had encryption in place whose data was breached nonetheless because it was low quality or improperly implemented, hadn't been turned on, things like that. And so you have to understand what the level of protection it actually provides. And that's going to be very important in the decision-making process of reporting a breach that has been where encryption has been implied. You actually have to make sure that the encryption solution was doing its job and the data that was leaked, so to speak, was actually encrypted, strongly encrypted. Controllers should also be familiar with the specifics of how their encryption product functions. And again, so there's from our understanding, there's really no way to get out of a pretty thorough assessment of encryption solutions that you have or that you're contemplating obtaining. The most recent word on encryption from GDPR, well, actually from the UK ICO's, the Information Commissioner's Office, was just back last December, just a month ago, where they said you can consider the state of technical development and cost involved when assessing what security measures to implement. Nice of them to let us, evaluate costs. But the key statement really comes next. It says, however, and again, I think that however is there because the GDPR does not specifically require encryption. It advises you of a process of assessing the risk to the data subject and then putting appropriate state-of-the-art measures in. So, however, as encryption is an established, well understood, and widely deployed technology that is available in a large number of solutions and it can be implemented relatively easy, it is likely that in many cases it will form part of the technical measures you look to put in place. So again, as you're deciding how you're going to better protect the data, their understanding is that it should be likely that you're going to look at encryption. And they say because, well, there's a lot of encryption solutions available. And the one thing that we would probably take a bit of issue with is that phrase, from a consulting standpoint, is that phrase can be implemented relatively easy. That's true in some cases. Other cases, it's not. Proper implementation of encryption can be actually be pretty difficult, and we'll expand on that a little bit later. So just the summary of the expectations, right? Assess the risk to data subjects. Obviously, we have to do that based on the data that you hold for in their behalf, and select adequate state-of-the-art protections. Know the specifics of how your encryption solutions function and the degree and scope of protection the solutions actually provide. Understand what, when, and where data is protected, and just as importantly, when it is not. Encryption solutions, as a general rule, and actually I've never seen an exception to this rule, encrypt data, in storage and in transit. Sometimes it doesn't. It depends on how it's applied. It depends on the use case. It depends on a lot of things. So you'll really need to understand when it works, when it doesn't. Understand how to properly implement, maintain, test, and document your encryption solutions. Again, not really useful to have an encryption solution that doesn't work because it wasn't properly implemented. It hasn't been maintained. And of course, you've got to be able to test and document it, particularly if you're relying on it in a decision to not report a breach. GDPR only considers the adequacy of their protection. They talk about cost. It's as if they give you permission to look at cost and evaluate solutions. Again, thank you very much. But providing adequate protection at the least cost, that's up to you. And the large number of solutions that they talk about, and there are a large number, is sort of a good news, bad news story. Sorting out the least cost, technically adequate solution, that may not be so easy. So we've tried to do in this presentation and in documentation on our website, we'll tell you more about to give you a hand in sorting that stuff out. So just start with the basics. There are 4 cryptographic data protection functions. You can encrypt stored data. You can have cryptographic user authentication. And that extends to humans and machines. Systems talking to systems can be cryptographically authenticated. You can have cryptographic verification of data integrity, and of course you can have transmission encryption, HTTPS. You see the little green lock when you're out on a secure connection on a website, that sort of thing. So let's talk a little bit more about this confusingly large number of solutions. First of all, it's important to understand there's really not a case where you can't find an encryption solution, for any data that's manipulated, stored, or transmitted. Or created electronically. There's something out there that will work for that. There are encryption products and/or services for every single application architecture. Conventional web apps, progressive web apps, which are becoming more and more common. And a progressive web app just stores data locally, right? It can store a lot of sensitive data, just data period, out in the web cache, and in some cases even in the file system. There are client-server applications like Microsoft Outlook and Exchange, standard client-server application. Their cloud-native apps have grown hugely in the last few years, which are basically a bundle of microservices from sometimes from different vendors that are bundled together with usually with a user interface wrapper, right? They're all pretty much cloud-based. You're also getting the incredibly rapid rise in peer-to-peer networks, and this is the peer-to-peer networks is the domain of the Internet of Things, and more Internet of Things are bearing personal information, wearable devices, appliances in hospitals. We're beginning to see the connected refrigerator and the connected washing machine and dryer, so that they can communicate back, when they have service issues. Well, in some cases that requires those peer-to-peer networks to have information about you, your address, when you bought the machine, what your warranty program is. There's an abundance of that kind of personal information in peer-to-peer networks, and by all indications, that is going to grow quite a bit. There are encryption solutions for every device type: servers, desktop, mobile devices, IoT devices. There's encryption solutions for browsers, and nowadays the browser cache, because of the growth of progressive web apps. There's encryption solutions for every platform. Windows, Linux, OS X, and iOS for Apple, for Android. There's encryption solutions for COBOL and Fortran. I mean, there's, and again, you get the sense of what GDPR means in the prior statement that we talked about. They're readily available solutions for everything. We kind of break the types of solutions down into two sort of major buckets. The first is bolt-on encryption solutions. And you can tell a bolt-on solution is something that's entirely separate from the application that creates, stores, and transmits the data. A lot of these bolt-on solutions, they may protect multiple types of applications, right? So they're something that they may integrate to a certain extent, but they're really completely separate from the application itself. And that's why we call them bolt-on. They're just added on. They can be there or they cannot be there. They really don't affect the operation of the application that is processing the data. They tend to be centralized and highly specialized. They come as applications. They come as hardware. They come as services, APIs. You get some that are just specialized for one cryptographic function. One common one is cryptographic authentication applications and services. You tend to see those associated with single sign-on, where you can have something that authenticates access throughout an organization in a lot of different applications. So they've essentially abstracted authentication to an outside solution, as it were. You get encryption key generation and management services and hardware, and these are very often associated with on-prem databases. Or in sometimes cloud databases, obviously, as well. But modern databases can encrypt and decrypt for themselves. They can run encryption protocols, but they don't generally have any way to generate and manage the keys for that encryption. They'll rely on an external, hardware or service to do that. So those are kind of the common bolt-on encryption solutions. Built-in encryption solutions have been pretty rare, but we have seen a spike up in their use, and we think that spike is going to continue for one simple reason: people want organizations don't want the responsibility for encryption, so they are going to be tending to buy applications that do the encryption for them. So the built-in encryption solutions, they're going to provide one or more of the cryptographic functions, preferably all of them. So they're going to encrypt stored data, they're going to encrypt data transmissions, they're going to cryptographically authenticate users, they're going to cryptographically verify data integrity. So if you're going to purchase an application that does encryption for you, the preference is that it does all of those things. Otherwise, you might have a hole that you've got to fill with a third-party solution. One of the reasons why I think we're seeing more and more of these built-in solutions, and actually that's a good thing, we'll discuss why that's a good thing, is that there's in the last couple of years there are just lots of encryption libraries and software development kits, the thing that application developers use to build their software, that are available for every application architecture, device, and platform, all that stuff we went through in the prior slide. What that essentially means is that it's pretty straightforward to build encryption into an application the vast majority of the time. So, we're used to rapid release schedules on a lot of applications, and we tend to get hit with new features, or we tend to get hit with patches when they change out in, libraries or update them, that type of thing. So the sort of churn that you get in software development, this constant flow of updates and things like that, are just a normal part of the development cycle, and it's not that difficult to make a normal part of the development cycle to add these encryption libraries and software development kits. So given that is the case, and given as developers ourselves, we understand the level of effort necessary to apply these things, we advise our clients to adopt a new attitude. Ask your application providers, why am I paying you for your application that's putting me at risk? The level of effort to build encryption into the application and offset that problem for yourself is just not that high. The further breakdown is package versus custom apps. All right, so package apps are what we used to call shrink-wrapped apps. Shrink-wrapped applications. When you actually go to the store and buy an application with this box with the CDs in it, that type of thing. Packaged applications, you as a customer really don't have a great deal of control over new features. You're going to have to kind of wait for them to kind of get up to speed on doing built-in encryption. However, there are companies that do an extremely good job of built-in encryption, and the one that comes to mind here that most people are familiar with is Microsoft Office 365. If you have a E3 or higher license, you have Azure Information Protection, then Office, Outlook, things that are running or stored in Azure, SharePoint. They have done a really excellent job, actually, of building in encryption specifically for GDPR compliance. They do a very good job of giving you the tools necessary to document that stuff, necessary to protect the data. Now, they're really out on the leading edge on that, and we're hoping to see a lot more shrink-wrapped applications begin to build in applications. But our advice, again, to our clients is all things being equal, you have two applications that will accomplish the same job, but one of them has built-in encryption and one of them doesn't. We tend to favor the ones that have built-in encryption because, that problem is taken care of by them. It's not on your plate. Then there's the domain of custom apps. Custom apps are purpose-built. They tend to be highly specialized. We were talking about existing apps, or we're talking about new apps that you might have built, or if you have an internal software development shop, even things you might build for yourself. And that's where you have a lot more power to request new features. Your requests are respected. You're an important customer to them. So if that's the case, if you're using custom apps, say as a controller, if you're a processor listening to this webinar, same thing applies. Press your application providers to build in encryption. Again, it's just not that hard. Another solution is to migrate your legacy apps. Some older apps, they're in needing of updating or maybe major rework anyway. So we've seen a lot of migration of existing applications to infrastructure as a service, platform as a service, software as a service type of situations. Just make sure that if you do that, you go to an as a service, whatever the first initial is, that features state-of-the-art appropriate encryption. Again, it doesn't make a lot of sense to go through the brain damage of porting an app over and migrating it to something only to find out that you still have to do, and manage the encryption and so forth yourself. So just ask the question. A real common example, again, that we see, and this is probably just due to the nature of our customer base, is the porting legacy apps to Microsoft SharePoint. Microsoft is, again, and there's a ton of third-party companies that support this as well. Look at SharePoint is an application development platform. The nice thing about it is, again, if you have the appropriate license and it's configured properly, they do a really good job of all 4 of the encryption functions. So we're going to go through a little brief, we're just going to call it a training video right here. And what we want to do is kind of highlight some of the common problems that we've seen when people do implementation of encryption solutions. And this shows up in how they buy things and how they are sold things. So this training video is really about what you should not do. So let's take a look at this.
And you're going to scrape off about a pea size and put it where it hurts. So today I'm just going to put it on my wrist, put about that much on, and you're going to rub it in. You're going to rub it until it disappears. And it's that easy. Simple and easy.
Now, we hope you appreciated the humor in that, but you know, there are 10 questions that you should not be afraid to ask when you're examining any kind of encryption solution. And what we want you to do is to avoid what we've come to call the magic encryption cream problem. We have seen, unfortunately, too many times people who have an encryption solution and they assume simply because it has the word encryption attached to it that their data is not going to get breached. Hey, we put an encryption thing in, we're all good. As you'll find out as we go through these questions, that's not necessarily true. The other thing is, again, it's how you make the decision and it's how you're sold. Some encryption solutions, you know, and I give you an example. We're beginning to see all the time people who sell encryption solutions that says we're GDPR compliant. We're GDPR compliant. You know, no solution is GDPR compliant. You're only compliant with the GDPR if you have a breach and the data is protected by encryption. So they're implying that if you buy their product, that you're going to be compliant, and that's not necessarily so. It depends on the nature of the breach. It depends, again, on all the things we've talked about, how it was implemented, and what it covered, what it did, and what the specifics were around the potential reportable breach. So to that end, we've given you these 10 questions, and we're going to run through them very, very quickly. And I'm going to start with the first one is a when question. When is stored data encrypted? At creation or sometime after? This turns out to be a really, really important question. If stored data, if the answer is at creation, all my data is encrypted at creation, okay, that's outstanding. And unfortunately, that's not normally the case. If stored data is encrypted after it's created, the next, you know, sort of sub-question of that is how long is it before it is encrypted, right? And the reason why that's an important question is the risk of breach increases the longer that sensitive data goes unencrypted. Obviously, people realize that they need to be able to find their unencrypted data that's sensitive content and then get it encrypted as quickly as they can. So with the GDPR, we've really seen a boom in classification systems that recognize data patterns. They'll go out and they'll surf all of your data. They will look for specific patterns like maybe it's medical terms, it's a credit card number, it's some kind of social ID. So, but you know, and those systems are great, and if that's what you have to do to start getting stuff encrypted, by all means go ahead. Just understand that not all sensitive data fits those patterns. It is pretty unlikely that if you run a classification system and then it marks all the data that finds, ships it off to a secure drive, an encrypted drive somewhere, it's pretty unlikely that it's going to catch all of the sensitive data. Right, and that can be a problem. So these classify then encrypt solutions do not mitigate the risk of sensitive data that's missed by the classification system. So if that is the sole thing that you're relying on, just be aware that there is going to be pretty likely some degree of sensitive data that will be missed. If that stuff is breached and out in the clear, you know, as clear text, then you're, you know, again, you're right back to where you started from. You've still got a reportable breach. Where is it? Where's that data stored, right? We all understand that there are for fixed storage locations, there are, you need to find out if they're in GDPR permitted locales. If not, move them. But you probably ought to consider data stored on end devices as well. We've seen situations, say in a client server application, where you've got encrypted data in the database, but the web app, especially a progressive web app, is able to download sensitive data and store it on the end device that's not encrypted. We've seen it the other way around too, where you have a good mobile device management policy in place, so all of the company end devices are encrypted, but the information on the server, the database somewhere on-prem is not, or in the cloud is not encrypted. So make sure it's encrypted in both places, and find out what the status is. Who has it? Who has your data? Who has access to decrypted data and encryption keys, and how are they authenticated? That's a really important question, because to a large extent, you've got two risk domains, right? You've got the information in that can be properly encrypted, strongly encrypted at rest and in motion. That's a good thing, but you can't work with encrypted data. Somebody's got to have access to be able to decrypt it, to do work, to be able to do further processing, to read what's there, and so forth. So you want to start with a list of who has access to and the ability to decrypt data, who has access to your keys, and how are those persons authenticated. It is hard to overstate this case. If you invest a lot of time, money, and effort in encryption, and you have weak authentication, you likely just wasted a bunch of time, effort, and money. And again, you can have the strongest encryption in the world for stuff in storage and in transit, but if getting access to that data and then, say, exfiltrating it is as simple as flipping over a keyboard and getting somebody's password, chances are you're going to get breached at some point in time, because there are people and systems, botnets and viruses and malware of all sorts that are constantly looking for quick and easy ways to be able to circumvent passwords. So then that's the reason why we recommend, at a bare minimum, two-factor and better multi-factor authentication. Yes, we know that it's inconvenient, and it's going to be that way for some time, but that's going to be your decision to make. Do you trade convenience for security, and our security for convenience? And in our minds, given the potential damage that can arise from reporting a data breach and violating the GDPR, yeah, it's probably worth it. If somebody else holds your keys, common for people to put stuff up in encrypted storage as part of what they pay a cloud processor for. Just remember that if they hold the keys, they have the access to the data, and they are a processor. Just make sure you're appropriately contracted with them. How hard is it? How hard is it to implement, test, maintain an encryption solution, and who is going to do it? And that who is going to do it is actually a pretty tough question. Encryption is on the rise to a large extent because of GDPR, but the people that were able to implement, maintain, properly test solutions were scarce before the GDPR arrived. They're even more scarce now. So you really want to do a good evaluation of the level of effort, and again, particularly for those solutions that may give you very good results but are just hard to implement and maintain properly. To get a handle on that, what I'd recommend that you do is go out to YouTube and find the video from John Gator, who is the Chief Technology Officer for Thales. It's out on YouTube, and I mean, I think they are now the largest encryption services and products company in the world. They've done a bunch of acquisitions in the last couple of years. A great little video called "Why Johnny Still Can't Encrypt," and what is good about that is it'll give you some idea of what you need to staff for, things you need to look for to better maintain encryption solutions and so forth. So that's a pretty useful video. It's worn out is the next question. Can we get a replacement? So encryption, question number 5 is all about the fact that encryption algorithms decrease in strength, right? They start They're kind of like people. They start dying the day that they're born. Eventually, every encryption algorithm will become hackable, and it will be deprecated, or it'll be put on some list where it says, hey, it's weak, you shouldn't use it. Again, it's still around, right? But you just shouldn't use it because it's not doing the job anymore. So everything eventually becomes weak, which means that everything is going to need to be replaced. Now, it used to be that the replacement cycle was somewhere around 5 to 8 years. You would have to look at upgrading your encryption. Quantum computing is liable to change that. And now, the scare, the sort of fear mongering thing is that quantum computing is going to burst on the scene. Oh my, and then everybody's sensitive data is going to be, decrypted and out in the wild all at once, and look, guys, that's not going to happen. That's just people, raising alarms about things they don't really understand. Every every government, all kinds of institutions, universities, and things like that are currently working on advanced quantum cryptography. So about the time quantum computing comes to the fore and is a threat to current encryption algorithms, they'll be met by quantum cryptography. What that does mean is that you're going to have to replace the encryption algorithms and things that you have in place, and because of the acceleration that's probably going to attend quantum computing's arrival, you're going to have to do it probably pretty fast. So you will need a solution that has replaceable encryption, and not every solution does. So some of the encryption algorithms are non-pluggable. They're kind of hard coded in, and then they get old, they get deprecated, they get weak, and you're kind of have painted yourself into a corner. So just ask the questions about the level of effort and the ease by which you can not only replace the encryption algorithm, but remember you're going to have to reprocess all of the data that is encrypted with the system that's being replaced. Can you find it? Can encrypted data be searched and modified to facilitate data subject rights? It kind of used to be before the GDPR that we could do a pretty cursory search of data if we needed to, and if we found it, that was great. If we didn't find it, it may not be that bad a deal. But with the exercise of data subjects right now, you really need to be able to find this stuff. Some encryption solutions, not many, but some, don't really support search. So you get yourself painted into a corner where you've encrypted a whole bunch of data. Let's say it's from a classification system, or it doesn't really matter how you did it. You've just got a lot of stuff that's encrypted, and it turns out that searching it is either very difficult or it's very computationally expensive to do that. So just make sure you understand how searchable the data is in any encryption solution, right? So there's a wide range of dead simple to very, very difficult. Just make sure you know where your solution is on that continuum. Okay, is that right? Yeah, question number 7. How is data integrity assured? Is cryptographic integrity verification implemented in solution, right? And then there's some further questions, kind of fine-tuning questions. Yes is the answer that you want, obviously, but if the answer is yes, how are integrity issues communicated? So we have seen solutions where integrity is checked. It gets poked into a log that nobody looks at, or somebody was not aware that they had to be able to hook up to their other, cybersecurity systems, just to put a general label on it, so that somebody could be told that hey, that looks like this file has been accidentally or maliciously altered in a way that raises concerns. Now, obviously, I shouldn't have to say this, but I will anyway. The whole thing with integrity breaches is that you have to be able to roll back to a known good state. So if you have fantastic cryptographic integrity verification and a great method of alarming that says, hey, this data's been altered, it's, Houston, we have a problem, and you have no good way to roll that data back to a known good state, well, their cryptography didn't help you not have an integrity breach. So just take that in mind. How is, can they hear us? How is transmission encryption quality assured? Transmission encryption is pretty ubiquitous today. It's actually kind of rare to go to a website that doesn't have the little green HTTPS lock on it. People have gotten the message. They need to encrypt their traffic coming out of their websites. The problem is that quality is sort of all over the roadmap, and there is wide-scale continued use of deprecated or hacked connection encryption, and it is a pernicious problem in general, and it is a particularly pernicious problem in email. If you set your email server where you'll only send or receive email that has come through a high quality, properly implemented TLS connection, which is what it should be doing, then you're going to end up with places that you can't mail to and people who can't mail to you because, again, you can only control what your mail server does. You can't control what theirs does, and that's just problematical. So you may want to consider in some cases solutions that provide you with high quality transmission equipment, transmission encryption from end to end. Outside of a couple solutions, again, Microsoft Outlook 365 comes to mind if you have the right version and if it's properly done. A lot of email systems don't do a very good job of managing encryption quality, connection quality. So just understand how that's maintained, how it's done. And then the next question is, where are you going with that? And this is question number 9. How is the transfer of decrypted data constrained? And here's what we mean by that. Human beings and even systems that withdraw encrypted data can't work on data while it's encrypted. They've got to decrypt it to be able to do work. And what that normally means is that there's some way to be able to transfer that decrypted data. Again, maybe stored encrypted. Let's just say it's something simple. Let's say it's some spreadsheets or some Word files or something like that. If you're going to work with them, you've got to decrypt them. The question is, does your application, and most of them do, allow you to move that data, to email it to somebody, to text it, to download it to removable media? So how is that constrained? Right, the sort of the first level is just doing it by policy, which is essentially training people, hey, don't send stuff outside that you're not supposed to have. You could get us into trouble, or you get yourself in trouble and get fired, whatever. But it's only because you ask for it not to be done. There's no technical constraints around that. Also understand, if that is the case, and some malicious insider or somebody on the outside gets a hold of the credentials of somebody who has the capability to decrypt data and email it or text it, or move it to a place it's not supposed to be, upload it to Dropbox. I mean, you name it, right? If they're able to do that and their credentials are compromised, then they just defeated all of your, carefully crafted and possibly expensive, third-party encryption solution, right? So just be aware that, again, you can have great encryption, all 4 of the cryptographic functions in play, and if it's easy for people to get to that, or it's easy for insiders to accidentally or maliciously spill it, then your encryption solution is not going to protect you. So is transfer constrained by analytics? And this is very common nowadays, and it's a good thing, right? You again, these are sort of scanning or analytical utilities that are going to look at the content. In the case of data loss prevention, it's going to actually examine the content, analyze it, and say, hey, does this email or this document or this database query, does it have information in it that it should not have, that violates our rules? And it will stop it sort of at the border of your organization. They don't catch everything, but they're catching some stuff, or hopefully most stuff is better than nothing. So that's a real good thing to have. And then there's user entity and behavior analytics. UEBA tends to be things again that actually look at human behavior, not at the content. It looks at Bob and Sally, and they download an average or 50 files a day, or that type of thing, and then all of a sudden they're doing 10,000, right? That tends to raise flags and say, hey, where are you going with that data, right? So those are good things as well. So that's the sort of the second level of constraint. Is the transfer constrained by the application handling the data? That used to be called digital rights management, but that's really kind of an old term now because it implies hardware encryption key like on a DVD player tries to keep somebody from playing a pirated clone DVD. That went by the wayside almost as soon as it came out because it simply didn't work very well. However, information rights embedded in the application, again, this is going to be typically one of those built-in encryption type of solutions, is very valuable because what it tends to do is keep a leash on your data not only inside your organization but outside your organization. You can constrain whether people can forward data that you've sent to them. You can control the lifespan of the data and so forth. So that's the highest level of constraint and basically being able to maintain control of your data not only in your network but even when it's on somebody else's network or device. So the 10th question is, does it play well with others? And this is really related to the question that we just looked at. If you're going to do data, DLP and UEBA, the data has to be available. What that typically means is that encrypted data has to be decrypted momentarily at least, so that it can be examined by DLP and UEBA systems. UEBA systems need to be able to recognize when somebody's working with encrypted data. So really this is about integration and interoperability. If you're going to or may contemplate putting in these systems in the future, just make sure that the encryption solution that you have or that you're thinking about getting actually will integrate with those systems. Not all do. So we're going to finish up here with documenting compliance, and we have tried to make this very, very simple for you. We published iComply365's Guide to Encryption for GDPR, and this is a little bit deeper dive than you're going to get in a 45-minute webinar. It will help you understand encryption as it relates to the GDPR. So it's kind of again a guidebook. We also prepared a set of gap analysis questions and methods for how to use them. And this was actually a surprise to us, as much as encryption is rising in popularity because of GDPR and other regulations, and simply because people are tired of getting their stuff stolen. We looked around everywhere for a sort of an objective encryption gap analysis tool, and we couldn't find one. So we wrote one ourselves. It is objective. It doesn't slant toward any kind of technology or approach. It just gives you more fine-grained questions than the 10 that we've given over, and some methods for documenting your answers that should meet GDPR's documentation requirements. Both the guide and the tool are written in plain language. You do not have to be a cryptography expert to use them at all. This is actually written more for the data protection officer or somebody who has that role. There's enough technical information, in the questions for the CISO or somebody of that nature to be able to use the gap analysis tools effectively. But again, we wrote this for the non-technical person who has the ultimate responsibility in organization for GDPR compliance. So they're pretty simple to use. Both of these are available. There's no charge for them. They're on the iComply365 website. And we'll end up with this. If you have questions or if you need help, just contact us. We'll do the best for you that we can. So we hope you have enjoyed this and that it's been fruitful. And again, call us if you need a hand. We'll be glad to help you. Everybody have a good day.